Hi, now we are going to understand all the aggregation operations in PySpark. We will start by creating a data frame, then check out the main aggregations like count, min, max, sum, and then we will understand the group by and having clause, followed by the collect set and lists, and then we will discuss the more advanced aggregation, which is Windows functions like row number, rank, dense rank. So all these we will go through these one by one via a demo example. So let's get started. Let's start by creating a data frame. So we are going to use this particular table and create a data frame using spark.read.table. And here let's see what kind of data it contains. As we can see, it is transactions data. So we have the transaction ID, customer ID, franchisee ID, date time, product. So all this transaction related data we have here. So if we want to do aggregation, so we will start with the very simple one, which is the count. So if we do df.count, we will get the count of records, how many records are there in this data frame or in that table. So this is how the simple aggregation looks like. Similarly, there are other aggregation named as first, which will return the first row from the data frame, and similarly we can get the last row from data frame as well. And then comes like more useful and different aggregations. So let's say what we want to do is we want to get minimum and maximum value of the quantity. So this is how we do it. We do df.select, and then we are selecting here the minimum value of quantity and maximum value of quantity. And in PySpark, all the functions we need to import them from this PySpark SQL functions library. And after that we are displaying the output. So now we will get what is the minimum quantity in that table and what is the maximum value of the quantity. And similarly, we have these other functions also like sum and average. So these will provide the total sum of quantity in all the rows and average of quantity in all the rows. So that's how these two functions work. And all these operations we can do in SQL as well, which is also very similar and easy. This is our table name, and we simply do like select count star, which will give the count. We can get min max values of quantity, average or sum of quantity. So all these functions are directly available in SQL as well. So this is how we can get exact those values in SQL as well. Next, let's understand group by. So why we need group by is that, so without group by we are able to get the aggregation, let's say average of quantity across all the rows. But what we want is, let's say we want to understand that for each payment type, for example, here we have this column like a payment type, payment method, sorry, for different payment method, what is the average quantity. So for each of them, if you want to calculate separate aggregation, that is where the group by comes into picture. So here we are doing the group by payment method and then doing a count. So what it will do is, for each of the payment method, it will return the count instead of the total count altogether. So now we know that for MasterCard, we have these many records. For Visa, we have these many records. So like that, we can do using group by. And instead of count, we can get same way like the average, sum, min, max, whatever we want to do. And the same operation, it is available in SQL as well. So in SQL, it is a slightly different way of using. So the group by clause we have to mention after the table name. So we are doing the group by based on this particular column, and the aggregation that we are selecting, we need to select it here. So what we are selecting is the payment method itself, and then the aggregation function. We want the count and the average of the quantity. So that's what we are getting the same output here as well, along with the average quantity. And one important thing about group by is that in the select part, we can take only the columns which are either in the group by part or those are some aggregation. We cannot select all the other columns like the transaction ID, the customer ID, all those we can't select. We can only select the grouped by column and the aggregated value. That's how group by works. And after doing the group by, if we want to apply some kind of filter, let's say here we have done a aggregation, and let's say what we want is we want the uh, payment method and entire data only where the count star it is greater than, let's say, 1100. So for that kind of cases, we have this having clause in SQL. So if we apply this having, now we can mention that having count star greater than 1100. So if we run this, now we will see only two rows where the count is greater than 1100. So that's how this having works. And it is similar to the where clause where we apply the filter, but the special thing about having is that it is applied only after the aggregation. After it has done the group by, then based on the aggregated value, we can apply any filter. So that's where group by and having are used in a combination. And if we want to do something like having in terms of PySpark, then there is no separate having clause in PySpark, but here a normal filter can be applied. So let's say here also we are doing group by and count, and then simply we can apply it as a filter, like filter the data where count of this like the value of this count it is greater than 1100, and then we display that. So the same output we will get here as well. And next comes another different type of aggregation, which is collect set and collect list. So let's say the average, sum, count, all these things, right? We normally do these these for the numeric columns, like we can calculate average of numbers, sum of numbers. But what to do with the string types? Or like in general also we can use these collect set. So let's say if some column contains string or any data, basically what we want is we just want to collect their unique values. So for example, for a given for each of the payment method, what are the different products which has been bought? So that's how as a list it will return the data. So let's see the output so that we can understand it better. So here we can see that for this MX payment method, these are all the products which were bought. So these 5 products has been bought, and this is a array. So we get this consolidated array, and this can be applied on any type of column, on strings or any other types like numbers also we can apply this. And this collect set it gets the list which is a distinct of all the data. Like if there are repeated products here, it will take only one value, it will not repeat. But in collect list it will repeat everything, even if the same product is again and again. It is basically the consolidated list, it doesn't care if it is repeating or not. So that's how this collect set and collect list are used. And both of these are directly available in Spark SQL also with the exact same name. So this way, after doing the group by, we can use this method and then use these two aggregation to get the exact same output. And next comes the more powerful and the more discussed aggregations, which is a window function. So normally in interviews also this is asked a lot. So we will understand this in more detail. So let's understand why exactly do we need a window or window functions. So these are also aggregation, but these are used when the group by is not enough. So if I take an example here, so let's say here we are doing a group by payment method, and then we are doing a average, or we can do min max of quantity. But let's say what we are looking for is, for each of the payment method, let's say I want the customer name where the quantity is maximum. So this kind of scenario, it cannot be handled using group by, because group by, either we can take the grouped by column or we can take the aggregated columns. We cannot take the other columns, whichever we need based on that aggregation. So that is where the window function comes into picture. So if we take our scenario again, okay, so let's say for each of the product, what we want to do is, we want to get like what is the maximum quantity that we can get using group by, but for that maximum quantity, who is the customer who bought that quantity. So that information we can't do using group by, we need to use window functions. So let's understand how exactly it is done. So for using the window function, first we need to define something called as window spec. And in window spec, we need to use this standard function window. And then we need to mention like what is our partition by column. Let's say in our case, we want for each product, we want the maximum quantity and the name of the or ID of the customer. So for each what category we want it, that is what we need to use in the partition by. And then we need to define a order by. So in our case, we want the maximum of the quantity. So what we will do, what it will do is, for each of the product, it will order the records based on the quantity column. And here we have mentioned that it shall be descending order. So the maximum quantity comes in the top. So this is how we define a Windows spec. And then after defining this spec, we can use different type of window functions like row number. It can be rank, dense rank, which we will discuss in more detail. It can also be min, max, sum. So these kind of aggregate functions we can define. So what it means is that this is the aggregated value we will calculate over this window spec, and then that calculated value, it will be added with this column name in the data frame. That's how it works. And then finally, instead of selecting all the values from this final data frame, we are selecting only the required columns like product, customer ID, quantity, and then the row number. So let's see how exactly does the output looks, so that we understand more how does the window functions work. So this is what it has done. So let's say for the first product, which is this Austin almond biscuit, for this product, it has ordered the quantity column in descending order. So the maximum is here and then it is decreasing. And for those quantities, the customer ID is also here. And it has added this additional window function column, which is a row number. Row number simply means it is like a 1, 2, 3, 4, like nothing special. So, but it is always ordered in the same way. So once this product ends, let's say for this product, it has done it for each and every entry. Then it will do the same for second product. So let's say this is second product. This is the maximum quantity for this product. These are the customers who bought these quantities. And then for these also, it will add the row numbers. So as there are so many records, let's filter some of these so that we can get more better perspective. So here what I'm doing is, instead of taking all these 500 or whatever maximum entries are there for each product, let's take only 10 entries so that we can understand it better. So I have applied a simple filter to take the records where this row number is less than 10. So now we can see this is how it looks. Let's say product 1. So this is a window. That's how it is called, a window function. So within this window, it has ordered these records by descending quantity, and then added this window function value, which is a row number in this case, which is 129. Similarly, this is the same thing it has done for the second window. So which is the second product. Here also same thing, descending quantity and row numbers. Likewise, it has done for each and every product. So now let's say if I want the customer, like for each product, what is the customer ID who bought the maximum quantities. So how I can get that? If I filter out the row number equal to 1, that means that will be the row with maximum quantity. So that's how, if we filter based on the row number equal to 1, we can easily get like who are all the customer IDs where the quantity is maximum. So this is the way we can filter it. So now we know that for each product, this is the customer ID who bought the maximum quantity for that product, and this is the maximum quantity which was bought. So that's the scenario or the purpose of using window functions. And this is one of the window functions that we discussed here, which is a row number. There are other window functions also which are also very useful, especially these rank and dense rank. Okay. And this rank and dense rank, these are asked a lot of times in interviews. So let's understand like what is the difference between these two as compared to row number, and how we can understand these easily. So to apply multiple windows function, the method is simple only, because these function also we will be using the same window spec. That means for doing calculating a rank or dense rank, the function, the window will be same, like partitioned by the product and then ordered by the quantity using descending order. Within that same window, we will be calculating these three functions. So all these can be applied together. And now let's understand what is the difference here. So here we can see the output from row number. Here we can see from rank, and this one it is from dense rank. So if we take the first example here, so the quantity is 60, 60, 60, same here. So if we see the row number, it doesn't care anything about the column which is used for ordering. It is always 1, 2, 3. That's how it goes. Wherein a rank and dense rank, those are the one which are same if the value in the order by column is same. So let's say if we, in our previous example, right, if we wanted the customers who bought the maximum quantity of that product, then using a rank equal to 1 will give the right answer, because all these three customers bought the maximum quantity. So using the row number, it provides only one of the customer, but there can be multiple. So these are the kind of scenarios where these two functions can be helpful. So in general, wherever they see a repetitive value, so they don't increase it. For same values, same quantity, same rank and same dense rank will be there. But there is a difference between rank and dense rank, which comes after the repetitive entry ends. So let's say here we have these three entries. When it will go to the fourth entry, So in rank, because it is the fourth entry, it will take it as 4. But in case of dense rank, it will not skip anything. It will take just the next value from the previous value. So if it was 1, it will take 2, 3. And if it sees the repetition again, let's say 42, 42 again, it will keep 4, 4. Then it will again take 5. But in case of rank, there can be gaps. So it is like similar to row number, but only for repetitive entries it will be same. But if repetitive entry is not there, it will again put similar to row number, like which position value is there. Whereas dense rank, it don't skip any of the value, and whether it is repetitive or non-repetitive, it will increment only by 1. So for same values, it will not increment. Whenever it's a different value, then it will increment by 1. So that's how these three functions, they have different uh, usability, different functionality. So depending on our exact need, we can use any of these three. And if we want to use the window functions in SQL, here also it is a similar way, but I find SQL more easy to use. So let's say this is our table name, and we want the product, customer ID and quantity columns, and then we want our uh, window function columns. So let's say row number over partition by product. So for each product, it will provide those details, and then order by quantity in the descending order. So this is what it will calculate as a function, and then it will give this as a alias or name. So this will be the name in the output. So this is how we can use it in SQL using the exact same way. So this is how window functions work. I hope you got the idea. So in general, we understood like how does the common aggregation works, when shall we use group by, when we want some aggregated value for some particular category, then we use group by. But along with the category and the aggregated column, if we want the other columns also in the data frame or output, then we go for window functions. And for collecting all the details other than numbers, or maybe for numbers also, like collecting them as a list or a set, that's where we use collect set and collect list. So this is all about the aggregation functions. So that's what I wanted to explain here. Thank you. Bye bye.